All right, you guys, so the other thing that we did today in class was multiplying exponents. And what we're going to look for today is some type of pattern or shortcut, if you want to call it that, of how to multiply exponents and then how to use that fact to simplify some exponents later on. So what I want you to do is evaluate each of these exponents right here. So use your calculator, for example, to do 5 cubed, and then multiply that times 5 to the 5th. Then do 5 squared, multiply that by 5 to the 6th. And go ahead and do that for each of these problems and see what answer you get at the end. So pause the video now and try it out, and then unpause when you're ready. Okay, so if you did this correctly, you should have gotten this same answer for every one. 390,625 for every single one of these. So let's think about why is that? Why were they all the same in the end? Maybe if we expanded these, it would help us to kind of visualize why all of these ended up being the same. So I'm going to expand a couple of these. I'm going to expand 5 cubed times 5 to the 5th first. 5 cubed is 5 times 5 times 5. And 5 to the 5th is 5 times 5 times 5 times 5 times 5. And if I count these up, so here's 3 factors of 5 right here. Here's 5 factors of 5. In total, how many factors of 5 do I have? And if we count these, it looks like we have 8 factors of 5. So I could also have written 5 cubed times 5 to the 5th as 5 to the 8th power, which is 390,625. Now let me skip to another one. 5 to the 1st power, which is just a 5, times 5 to the 7th, which is going to be 7 factors of 5. Let's see, did I get 7? 1, 2, 3, 4, 5, 6, 7. Okay, I think I did this right. 1, 2, 3, 4, 5, 6, 7. Okay, so in total, with my 1 5 right here and my 7 5s over here, I also get 5 to the 8th, which is the same as this over here. Next, if I did 5 to the 4th, I would have 4 factors of 5 times another 4 factors of 5. And in total, that is 8 factors of 5. So it's 5 to the 8th. So each of these ends up being 5 to the 8th. Even this one up here. Remember 5 to the 0 power? Anything to the 0 power is just 1. So you end up with 1 times 5 to the 8th, which is the same as 5 to the 8th. And let's look for a pattern here. Look at all of these. 5 cubed times 5 to the 5th. How did that turn into 5 to the 8th? 5 squared times 5 to the 6th. How would that turn into 5 to the 8th? What about the 1 and the 7? How is that related to 5 to the 8th? How is 5 to the 4th and 5 to the 4th related to 5 to the 8th? So right now in your head, I want you to look at these and pause the video and see if you can come up with some sort of pattern. Okay, so if you were not able to come up with a pattern, I'm going to show you a couple more examples and then hopefully you'll get to it. Let's say we have x cubed times x squared. Let's expand that out first. X cubed is x times x times x, and x squared is x times x. Now in total, when I count these up, that is 5 factors of x. And so I can condense that into x to the 5th. Now try to look at these exponents, 3 and 2. And if you haven't figured out the pattern, think about how 3 and 2 could be related to 5. And if you still don't see the pattern, we'll do a couple more. A to the 7th times A. And anytime there's not an exponent, by the way, I can put a 1 right here. So A to the 7th is A times A times A times A times A times A times A. Let's see, 1, 2, 3, 4, 5, 6. Yep, that's 7 A's. Times A to the 1, or A to the first power, which is just A. And in total, I end up with 8 factors of A, so that's A to the 8th power. And keep thinking about how are 7 and 1 related to 8? And how are 3 and 2 related to 5? And if you're really frustrated and you're really stuck, I will give you a clue. C to the 110th times C to the 63rd. Now let's look at this one. I do not want to write out C 110 times and then write out C 63 more times and then count them up in the end. If I do this, I end up with 110 C's and 63 more C's. In total, instead of writing those all out, I can just add together 110 plus 63. I can add the exponents because if I were to expand it, that's how many times I would have to write out C. And so that becomes C to the 173rd power. So the pattern here is that, let's say you have A to some number n times A to the m power. That's the same as A to the n plus m power. So when you're multiplying exponents, what you can do as a shortcut, or a quicker way of doing this, is just add the exponents, or add the powers, rather than having to expand it out. Does expanding it out work? Absolutely. Can it get really tedious and annoying and time-consuming? Absolutely. So that is why we want to think of some patterns and shortcuts in order to make life a little bit easier. All right, so that is what we learned in class today. I'm going to post these videos on YouTube of Exponents Day 2, and then I will also send out the copy of the homework and the key. Once again, feel free to email me if you have any questions.